So let's talk about the division algorithm. And the division algorithm is sort of like when you did long division when you were little. And when you said two numbers divide and you found the quotient and the remainder. And so what the division algorithm says is that for all integers a and b with b positive, so we're only going to divide by positive numbers, there exists unique integers q and r such that a equals b times q plus r. But I want you to keep this important fact in mind. That remainder, that r, needs to be between 0 and b. So the remainder has to be a positive number, and it has to be smaller than b. So when we do that, we call q the quotient and r the remainder. So think about the numbers 7 and 38. So if I do long division, 7 into 38, I say 7 goes into 38 5 times with a remainder of 3. So in this case, my quotient would be 5 and my remainder would be 3, because I could write 38 as 7 times 5 plus 3, and 3 is smaller than 7 and positive. So when you're doing the division algorithm, what you kind of want to think about is you could do this long division like that, or you could divide in your calculator and get the quotient part, the integer part, and then use the remainder. If you think about this in Python, q, the quotient, is that operator like this, and then r, the remainder, is that mod operator. So these are the Python operators that we could use to find them. So let's do some examples. Find the quotient and remainder when 18 is divided by 5. Well, what you know is that 18 is 5 times 3 plus 3. So the quotient is 3 and the remainder is also 3. If you did long division, you would say 5 into 18 goes in 3 times. 3 times 5 makes 15. Subtract, you get a remainder of 3. What happens when I do this with a negative number though, right? So 13 into negative 101. Let's see, 13 goes into 101 7 times. What's 7? If I use 7, I get 70, 91. There we go, 91, which leaves me with negative 10. The tricky part is that, remember, that remainder has to be a positive number. So I could write negative 101 as 13 times negative 7 plus negative 10. But then this remainder that I have here doesn't work because it doesn't satisfy that property of 0 less than r less than b. So when you're dividing by negative and you get this quotient, you want to up it by 1. So negative 101 is 13 times negative 8. When I do 13 times negative 8, I get negative 104 plus 3. And so that way the quotient is negative 8 and the remainder is 3. And the remainder now satisfies this property that the remainder has to be between 0 and b. So in your calculator, you could do negative 101 divided by 13. It'll give you negative 7 point something. And what you want to remember is you want to take this integer part and make it 1 bigger. So use your integer part, your quotient is negative 8. And then you can figure out your remainder from there. So we call q the quotient, and we could also denote it by this a div b. And we call r the remainder and denote it by a mod b. Remember, q is this operator and r is this operator. So if I want to find negative 111 mod 10 and negative 111 div 10, I want to use the same division algorithm and write negative 111 as 10 times something plus something. Now this one, the remainder, is going to be the mod, and this one, the quotient, is going to be the div. But remember, the mod, the remainder, has to be between 0 and 10, because 10 is my b. So in my calculator, I'm going to put negative 111 divided by 10. It gives me negative 11 point something. So I'm going to use my quotient q, because this is a negative, as one more than that, negative 12. And then I'm going to find my remainder. So negative 111 is 10 times negative 12 plus 10 times negative 12 makes negative 120. I have to add 9 to that to get to negative 111. So my quotient Q is negative 12, and my remainder R is 9. This is negative 111 div 10, and this is negative 111 mod 10.